Hello and welcome back to CST 2120. So in this lecture I'm going to cover web scraping. So I'm going to give a little bit of a short introduction, then I'm going to talk about how you can check whether a website allows you to scrape using the robots.txt file. Then I'm going to say a little bit about static and dynamic contents and the role that JavaScript plays in that. And finally I'm going to sort of explain how you can use the tool Puppeteer to scrape data from websites. Okay, so what web scraping is the process of extracting data from web pages that are written in HTML, CSS, and JavaScript. So I've got another recorded video on getting data from web services. Web services make data available in like JSON format, and you control the path and query parameters to get the data you want. With web scraping, you're pulling data from websites that are written for humans to view, so they're kind of pretty websites with lots of pictures, lots of CSS, all that kind of stuff. And so there's certain tools you have to use in order to get the data from there, and certain things you have to check to make sure that it's okay to take the data from there, yeah? So historically, there have been quite a few websites based on web scraping. So, property search websites used to scrape all the, details about properties from the estate agents' websites. Price comparison websites typically will grab data from different websites selling different products. Money supermarket is sort of similar technology, yeah? And in the middle of this kind of AI boom at the moment, so things like ChatGPT, they're often trained on data that's been scraped from the web. So there's a thing called a common crawl repository, which is like the entire web, archive kind of thing. So they often take these enormous archives of data from the web and use them to train AI models. So as I said, web scraping is pulling data from websites that are written for humans, yeah? And these websites have not been designed to be accessed by computers like web services are. And so the format can change a lot, right? So if they redesign the page, then all of your web scraping code is quite likely to break, yeah? Sometimes websites don't want you to take the data from them. So there was a big sort of legal action with LinkedIn, I think it was. And so in those cases, they can websites will often be designed to make web scraping harder. Sometimes they use a lot of JavaScript for that, but that's, as I'll explain later, doesn't really work anymore. But they might use really confusing kind of CSS rules or randomized CSS classes and IDs, this kind of stuff, yeah? And so if you want to find out which websites allow you to scrape data from them and which don't, what you need to do is read the robots.txt file that specifies the web scraping rules for a website. So I'll explain how this works, and then I'll talk about how you can actually pull the data. So some websites are okay with scraping. Some websites are only okay for certain crawlers to access the data and others not. And so if you want to find out whether web scraping is okay, you need to look in the robots.txt file, which is typically located at the root of the domain. So here's an example. This is like the John Lewis one. So as you can see, just go / and then type robots.txt to access that file. And you'll see that you have a bunch of user agent rules, and star just means all user agents. Sometimes they'll specify particular crawlers and rules to particular crawlers, yeah? Then they'll often have a whole chunk of stuff disallowing certain paths, yeah? So if you scrape from these paths, you probably could, but that's against the terms of use of the website. And obviously, if you're basing your company on data from John Lewis, let's say, and you break their rules, you're going to basically have legal action. Your company will fail. Yeah. So with any kind of commercial stuff, you definitely need to respect what they're doing, what they want you to do on their website. Yeah. So we have a lot of disallow rules. Sometimes you'll have allow rules, and the general rule is if it's not disallowed and it's not allowed, if it's just not mentioned a particular path, then it should be okay to take the data from it. Yeah, and similarly, if they haven't provided a robots.txt file, probably okay to take the data. Like some older websites or some ones done non-professionally will often just not have a robots.txt, and then you can probably just take the data. So if you want to use robots.txt correctly, firstly go to the website and find the path or paths that you want to take the data from. Yeah. Then when you found the paths that you want to take the data, you go back to the robots.txt file, and then if it's allowed, scrape the data, great. If it's banned, find a different path or website. And if it's not banned or allowed, as I said, should probably be okay, but don't quote me on that, yeah? And you'll often find with websites that they might ban certain paths, but allow others, and that you can get the same data from a different path on the website, yeah? So I'll give this a little example with John Lewis, but it's true a lot of websites that some of them don't like you scraping from the search path, because that costs them certain hits in terms of, the database and the server and all this kind of stuff. You can't necessarily cache search results, yeah? Whereas if it's like on the browse path, those are cached, they're on a content delivery network. They don't really care if you scrape them or not, yeah? So often it varies with websites, but sometimes search is banned, but browse is not, yeah? Not true of Amazon because they've got very efficient search, yeah? But true of John Lewis, as I'll show you, yeah? So let's have a little look at a couple of robots text files just to show you what I mean, yeah? So here's John Lewis, the main website, yeah? So if I'm trying to figure out what I can and can't do with John Lewis, I just go type in robots.txt after the domain, and I get here, yeah? And so here we've got different user agents, and I think them just for a single user agent here, and they're banning, a bunch of stuff, but we don't know what matters until we actually have a look at what the data we want to do. So suppose we wanted to scrape data from this path on John Lewis, yeah? We'd look at the path is search, and then we've got a query expression there, yeah? So now we can go back to this and see what they think about search, right? And turns out that, they actually disallow search, basically, yeah? So we can't use search on John Lewis, yeah? But what I was searching for here was mobile phones, and I found that if I just browse here to electricals, mobile phone accessories, let's just see if that's, that's banned, and I'm pretty sure it's not, at least it wasn't when I last checked. So you see here, they actually allow us to browse some of those paths of mobile phone accessories. You have to check it more carefully, but it seems that the browse path on John Lewis is okay, but the search path is not, yeah? Now let's have a little look at Amazon as a sort of another example here. If you look at their robots text file, again, bunch of complicated stuff, and you can see here they've got different user agents. They're banning Ital Spider from doing anything, or GPT bot or CC bot, but for most other bots, they have a bunch of rules. So again, let's have a little look here. So I'm looking here at the /s, which is their search path. So if we go into here, have a little look, and look for a /s, yeah. We've got rather a lot of stuff. Most of that is all customer reviews, stores, blah, blah, blah. So you can see by looking through this, they don't want you to access reviews, they don't want to access user data, but they're actually okay with you taking data from the search path because, this is all Amazon Web Services at the back of this, and they can do search very well and very efficiently. So they're not that bothered if you're hitting the search path, yeah? And also, it depends on the company, but some companies, are selling products very cheap, so they're very happy to be scraped, by price comparison websites, for example, yeah? Now, I'm going to come to this later, but this is the Middlesex one. So they're basically allowing all the named bots to do whatever they like, yeah? But they're banning, anyone they don't know from doing anything on their website, yeah? So it's kind of a bit of a funny one, that, and I'll come back to that later, yeah? Okay, so that's the paths that we can and cannot take data from, yeah? Just want to explain roughly how two main ways in which websites are architected, which affects how we can scrape data from them, yeah? So sort of maybe 10 years ago, the sort of standard way of doing, putting data into a page. So obviously websites are built with databases, right? So when you send a GET request to the website, then you have a script on the server of some kind. That script will ping the database in most cases, grab some data, it'll wrap that data in HTML, and it'll send a complete built HTML page with the data inside it back to the front end, yeah? So back in the day when I was doing a shopping website or whatever, I'd search for a term, and then the search data would be sent to the server. It would load it up with search results and send it back, and then you get this kind of constant back and forth of all the HTML and all the data being sent back and forth to the server, yeah, to and from the server. So it's quite a slow way of working, yeah, because you have to reload the entire page every time you're getting new data from the server, yeah. And if you're scraping that kind of website, it's kind of easy because all you have to do is have basically an HTTP client and then obviously some CSS parsing tools to be able to get the data. Yeah, the HTTP client can ping the server, get all the HTML, and then we can extract the data that we want from that HTML. Yeah. Now, more recently, many more websites have a different architecture pattern, which is actually much better in my opinion, where the server sends a basic HTML page. That HTML page has a bunch of JavaScript inside it. And the JavaScript will use AJAX to kind of ping the server, ping a web service typically, and pull JSON formatted data, and then it'll use a framework like React or Angular to insert that data into the page, yeah? So in that case, we can't scrape it just using a simple HTTP client, because all the HTTP client's going to get when it pings the server is this empty HTML page. To scrape pages like this, we actually need to have a browser that executes the JavaScript, and then when the JavaScript's been executed, the data's been loaded into the page, and then we can actually get the data out. Yeah. So there's a little example. So this is like an old school page, sort of just a fake example really. We basically have the server will send back this entire HTML document in which all the data is embedded, along with the prices. So this is easy to scrape with old tools like JSoup or Beautiful Soup, because we just ping it, get the HTML back, and extract the data. This is a more modern approach, the kind of approach I'm teaching on this module, where we just have an empty div, there's no data inside the page, and then we have our JavaScript, which will ping, in this case, like a dummy document, but obviously it would ping the web service that would then return the data in JSON format. And then we'd insert that data in the page. I'm doing this with vanilla JavaScript, but obviously I could do this using Vue or React or Angular. And then we get the same result. The page looks the same, but the mechanism for getting that data into the page is quite different. So some scraping tools only do not execute the JavaScript. They're just pinging the server and extracting data from the page. They will probably work, at a very rough guess based upon my teaching last year. Maybe half of the websites out there will work using JSoup and Beautiful Soup these days. But if we want to scrape all websites, we need to execute the JavaScript before we get the data from the page. And so we need a scraping tool that will execute JavaScript by controlling a browser. There might be other ways to do this, but the standard way of doing this is we have a scraping tool that can control a copy of Chrome or Firefox or whatever, and that has access to the data within Chrome or Firefox. That's typically how these things work now. And this is such a tool, right? So, I used to teach this with Java and Selenium, and this, and then so with Selenium you can kind of control browsers. But now this is a Node.js module, so I figured out how to use Puppeteer for that, and I'll give you a little bit of an introduction. But it's the same basic principle. And I have to say I rather like Puppeteer. So Puppeteer is a powerful web scraping tool running on Node.js. So we write JavaScript in Node just as normal. And what Puppeteer will do is it'll launch a browser, load the page into the browser, it'll execute the JavaScript in the browser, and then we can use CSS or XPath selectors to access data in the page. And Puppeteer is powerful because we can do anything we could normally do on a web page, like click on buttons, enter text, and all this kind of stuff. Simple to install, really simple. All we have to do is npm install Puppeteer, standard method of installing libraries on Node. But what's particularly impressive about this is it also puts a test version of Chrome on your system, not inside Node modules, and it uses this test version of Chrome to actually do all the stuff about executing JavaScript and running the browser. So it's really quite a neat package. So just bear in mind, if you're using cloud synchronization and you try and run your code in a different computer, it won't work. You have to reinstall Puppeteer, so it reinstalls that new version of that test version of Chrome. So just thought I'd put together a simple example that extracts course information from the Manchester University website. So, obviously this is generalizable. It's just a simple example of how to use Puppeteer to scrape data. And I had to use Manchester because, as I explained, the Middlesex University robots.txt only lets named user agents get access data on the page. So this is the Manchester University website. And you can see user agent star, and then there's a few things that their campaigns are basically and reports they don't want people to access. The rest they just don't care. So here's the BSc Computer Science in Manchester, and we're going to pull some data from that page. So this is the Puppeteer code, and it's pretty straightforward, and this is pretty much copied verbatim from the Puppeteer websites, and they've got loads of really great documentation. So I recommend looking there if you want to do anything more complicated than what I'm doing here. So we specify the URL, and then we do Puppeteer launch, and we get this headless mode, and I'll show you the difference, but unfortunately the headless mode doesn't seem to fully work on my system. So normally headless means that it will still it'll still launch a browser, but you won't see any of the graphical components of the browser, and that's for running on the server. So if I'm running in the cloud somewhere, obviously I don't want this to try and launch a graphical browser, but it can still execute the JavaScript without actually anyone being able to see it, by running it in headless mode. But for some reason on my system it doesn't work, but that's a detail, because for your purposes it doesn't matter for this course. And then we basically wait for the browser to load the page, and then we go to a particular URL, in this case the Manchester University one, and then what I'm doing here, just a little demo really, and I'll show you what this does, is when the when the page loads, Manchester University, like pretty much everyone, has a kind of cookie stuff, right? And I could, in fact, scrape the data without clicking on this button, because as it happens, the data is all loaded in the background, and then the button just prevents you seeing that data. But just as a demo, I thought I'd show you how to do this. And so we can actually click on that cookie button, and then we can actually just access the page then, yeah? And then all I'm doing is I'm logging out the HTML on the page just as a demo, yeah? So this is the cookie button here, right? So if we click on this, the Puppeteer will enable us to click on that button in the browser and then get rid of that GUI, although in fact, we don't actually need to in this case, yeah? And to click on that button, and with all web scraping, this is the case, we need to figure out a selector that allows us to find that button in the HTML. And so I'm using the inspector tools here to figure out that the button ID is on trust, one trust accept button handle or whatever. And then all I have to do is wait for the selector, and then I can click on it, yeah? So with all web scraping, we're figuring out the paths or the CSS selectors so we can pick out the elements we want, either to get the data or to click on the buttons or to enter text, etc., yeah? And then I'm logging out the page contents, yeah? Okay, so just show you that code running, and then we'll talk about the thing. So I've written two examples, and I'll come to the other one later. But this is the code, basically. There's the URL. I've got headless set to false there, yeah? And then we're waiting for the cookie button. I don't know why I disabled that, but oh yeah, I don't know why I disabled that. And then I'm not going to close the page here, but obviously if we're running a real thing, we'd close the page, yeah? So let's run that, and I'll show you what it looks like, yeah? Okay. So now it's launched the browser, it's gone open a new tab, and then we got the accept all cookies button, yeah? But supposing I wanted to click on that, what I can do is I can open up the inspect tools, right? And then I can use my inspector to figure out, click on this, and you can see here, I can find here, it's a button ID, so that means it's going to be unique on the page. So this, in fact, makes it really easy to click on. I don't have to do funny kind of nested selectors or multiple class selectors, which you'll end up doing with a lot of web scraping, because figuring out paths is really the hard bit, yeah? So I figured out that I need to click on that button, and then I can then rewrite my code. If I just close this down, if I can then, if I put the click back in, then run it again, and we can see it's launching the browser, and it's clicking the cookies, and then in theory, if this wasn't loaded in the background, we'd be able to access it, yeah? And then what I put here is just to sort of finish it off nicely. What it'll do is it'll do all this, and it'll close down the browser, you know, by itself, yeah? Yep, and so you can see it's all, you know, very rapidly launch the thing, launch the browser, execute the JavaScript, and then close it all down, yeah? Now this is what I mean by the headless, non-headless mode. If I put headless true, headless true, and run it again, then it still launches the browser, but it's kind of like an empty browser that doesn't really do anything. So I think there's some sort of bug or some configuration stuff I need to sort out there, but as I said, for your purposes, it doesn't really matter. I just leave it on headless false, and you can see what's happening. It's easier to debug and figure out what's going on, yeah? Okay, and oh yeah, and then what this is doing is, if we go to here, clicking on the cookie accept thing, and it's just logging out the page content, yeah? So you can see here, we've got a whole bunch of HTML, which is basically everything on that page, including the useful stuff and including a bunch of stuff that we're really not very interested in, yeah? So what we really want to do, obviously, I mean, getting the HTML is a good start, but what we really want to be able to do is to be able to select parts of the document object model and grab like headings, text contents, and all this kind of stuff, yeah? And two ways in which to do this are CSS selectors and also XPath selectors, and there may be others that I'm not familiar with, yeah? I'm going to focus here on CSS selectors because I covered them quite a lot in this course. And the first step is to use the browser inspect tool to figure out which selectors you should be using, yeah? And this can be the hardest part of web scraping. There's a few tools you can use to kind of map the paths of different elements, but it can take a bit of fiddling to get the right selectors so that you can get the right data that you want, yeah? So here, just in my demo at Manchester University, I want to get the headlines, course descriptions, special features, etc., the headers basically, as well as the text, yeah? To get the headers, turns out to be really easy. I can just grab those with H2. So all I have to do is use this double dollar notation. So it's a bit like jQuery for those of you who are familiar with jQuery. It's a double dollar notation on with the CSS selector here, and it returns an array of elements on the page that match that selector. Yeah. And then I can work through those elements, right? So here I've got, H2 header of H2 headers. And then I have to do this slightly funny line of code where I sort of evaluate node mapping to node inner text in order to get the actual text, right? So it's not a simple dot, but just copy that example and adapt it as you need to get the text within that particular element, yeah? And then I'm just logging out the H2 text there, yeah? So that's to get that. The headers, to get the contents, the text contents, it's a little bit more complicated. It turned out that there's like a text class inside which the paragraphs containing the text are. Yeah, so I just need p inside a .text class, and that worked quite well. And then again, I can do the same thing with this kind of evaluate. Once I've got the selected elements, I can then extract the text from in the usual way. Yeah. So let's just do a little demo. Yeah. So let's go back to my code here. And this time I'm going to run my other bit of code, which is here. Okay. So here's the code, same code I just went through. Yeah, let's just run it, show you how it works. Yeah. So it's doing the same thing. It's launching the browser, accepting it. And you can see here I've got the page text, which I'm outputting here. And then at the top, I'm outputting all the headers of all the different on that page. Yeah. Now, if we go back to the university thing, so to pick out this stuff, again, we're going to use the browser inspect tools, right? So we have to, if we want to figure out what the headers are, it turns out that these are quite easy, right? As I said, they're just H2 elements, each of which has a different ID, but we can ignore the ID because they're all just the H2s, basically, yeah? The text is a little trickier, but not super tricky. This is actually a really easy website to scrape, because you can see here I've got div class text, so just text I'll do, and then inside each of inside that I've got each of the bits of text, yeah? And if I look for another bit here, for example, again, it's the same thing, div class text, and then a p. So it's basically a p inside a dot text, yeah? So it's pretty easy, yeah? So done that, okay. So I've shown you how to do web scraping with Puppeteer, yeah? So as I said, with some websites you can use simpler tools. There's probably an equivalent to JSoup or Beautiful Soup in Node. In fact, I almost bet there is. But the simpler tools will break on a lot of websites because they're not executing the JavaScript, yeah? So that's why I've introduced Puppeteer, which should work on most websites, unless they're deliberately trying to block you, yeah? And as a general rule, obviously don't hammer the website with lots and lots of requests, because if you hammer it lots and lots of requests, they'll block you because they think you're doing some kind of attack, yeah? So when you're using web scrape data, you should always do, the web scraping should always be done by the back end of the website, yeah? You store the data in your database and provide it to your users through a web service, yeah? Don't try and scrape data on demand, yeah? So, because, I've seen some students, right, you type in a request on the front end of the website, sends a request to the back end, and the back end scrapes the data and sends it back to the client, right? Firstly, your website will end up getting blocked, right? Because you've got too many HTTP requests. It looks like because every single user is going to be basically scraping the website themselves, yeah? And obviously it's also going to introduce a significant delay, right? Because you've got to wait for the scraping code to execute the browser, to run the JavaScript in the browser and send it all back to you. It's just really ridiculous, yeah? So always do a back end, cache it in your own database, and then make it available through a web service. Okay, so this lecture I've explained how you can extract data from third-party websites, a process known as web scraping. So we're pulling data from websites designed to be read by humans, and to do that we're basically launching a browser, executing the JavaScript, and using CSS and XPath selectors to pull the data from the page. Yeah? You should always check robots.txt to make sure that this is okay with the person who's built the website. And Puppeteer is a very nice tool, I have to say, for web scraping, and this can do the job of controlling a browser to execute the JavaScript. And you just use CSS selectors with Puppeteer to get the data from the page, and it should work with most websites. Sometimes you have to play around with user agent. I didn't cover that here because the user agent's like a string describing, what browser it is and all this kind of stuff. Sometimes you have to sort of fiddle around with that to get the browser to look like a normal browser. Even when they're allowing web scraping, this can still be a little tricky, yeah. But I can help you with that in the labs, and didn't have any problems with that today, yeah. So as I explained, web scraping should be done by the server, and then you store the data in the database and make it available to the client through a web service. Websites are not built for making the data available to third parties through web scraping, yeah, obviously, right? So whenever they redesign the website, it's going to change the HTML and CSS on the page, and most likely your web scraping code will break, yeah? So if we did this commercially, obviously we have unit tests that check that the web scraping is working, so we'd know immediately when the web scraping is broken. If you want more reliable sources of third-party data, then web service is the way to go. But obviously they're not available. There's not a web service for everything. There's obviously a fairly limited range of web services, and that's why people often turn to web scraping. And that's it.